Today's workshop is going to focus on, so it's an introduction to charming, and yeah, like you all know, the Prince Charming's introduction to charming video. I'm talking about John Seeger's KubeCon 2020 something. However, yeah, there have been some changes in Charmcraft. There have been some changes in the Charm template. So Charmcraft init has changed a bit. So we thought, well, let's record a new one, and yeah, probably a series of more and more in-depth workshops should follow this one to provide a more gradual introduction into the world of Juju and Charms, which, as we all know, is pretty complicated. As for today's workshop, again, charming fundamentals. That said, I'm going to take for granted a bunch of things. Thanks, Eric. I'm going to take for granted a bit of an understanding of the Juju SDK, the Juju model. So I'm not going to explain too much in detail, what is a controller, what is a Juju unit. I'm not going to dive into the fact that there are machine models and Kubernetes models and so on. So I'm going to take all of that a bit for granted, and I'm going to try and explain like how do you get started writing a charm, very, very broadly. So FYI, this is my setup at the moment. Of course, if you are not using JHack yet, you should. It is the only the official and only developer tool for Juju beyond Juju CLI. I have Python 3.10, that's my local one. I have Juju 3.1.2 Snap, latest stable, microcates 127.1, and that's important because they need to match because of the strict confinement. Long story. LexT 5.02, multipass. I'm not using it right now, and I'm on Ubuntu because okay. What are we gonna do today? We're gonna write a charm from scratch, and you can write a charm for whatever you like. I thought, let's charm overleaf because Theodora is in love with overleaf. But yeah, that's a bit complicated. It requires interaction with some database charms, and it's more of a bundle. So yeah, I decided to go for something a bit simpler, and actually something that I've already done before because demo effect. So I don't want anything to go too wrong. So we're going to charm Grafana Tempo, which is a distributed tracing backend. It's all that you need to know about it is that it's just a piece of software, cloud native, containerized. So let's actually go and Google it. Grafana. Let's Google for Grafana Tempo container. All right. So let's suppose that you're given this task. You have to write a charm for Grafana Tempo. What do you do? What's the first thing you do? You Google, okay, what is this thing? What is this application? Let's suppose that you are actually, an expert of this thing, maybe not necessarily DevOps expert, but you know what it is. You're going to Google the thing. You're going to find a Docker container. Okay, that's useful piece of information because we're going to write a Kubernetes charm, it turns out. And a Kubernetes charm essentially wraps a container image. So you're going to need this container image because that is what your charm is going to run and operate. Then we could take a look at the contents of the Docker container to understand how the workload, so this Tempo in particular, how it is deployed, how it is configured, and so on. But before we do that, before we look a bit more at the application and how it's deployed, how it's configured, and so on, let's bootstrap our charm source. All right, so new folder. The first thing you do is, using Charmcraft, which is a snap. All right, sorry, you're very much right. So what I'm going to do is I'm going to run Charmcraft init. Charmcraft init is going to create for you charm repository template. to use 3, which is nicer. So let's see what Charmcraft Init has created for us. It has created, first of all, Charmcraft config and metadata.yaml. Together, those files, we call them the metadata of the charm. And in fact, I just heard news that in a future version of Charmcraft, they are going to be bundled in one big YAML file. So, I mean, soon they are officially going to be all in one metadata.yaml file, but for now they're still split. Yes, very good news. Then we have, the standard GitHub repository template things. So a contributing.md, license, README. And then we have some Python project because, yes, charms are written in Python. So we have a pyproject.toml and a requirements.txt. Now, since Jürgen is in the call, I have to say it's missing a tox.ini, but we're going to leave with that. Not everyone uses tox. Then it has created an src folder with a charm.py file and an integration and unit tests folders for our tests. Now, what is important to note at this point is that not all of this is, charm code. The minimal requirements to make a charm are, in fact, just the metadata.yaml file. I think requirements, yes. Then src and charm.py. All the rest is, and the metadata files. The metadata files, because they're needed they're required by Juju. But the contributing license, README, and tests, those are not really part of the charm. They're more part of the project. Now, let's take a look at what's in charmcraft.yaml first, because that's, that rarely changes. These are the bases. I've never had to change these. I always use the default ones, but basically, it's the basis that your charm is going to be built on and run on. So it's more like the build on is more of a Charmcraft directive, and the run one is more of a Juju directive. So it determines what's eventually going to run your charm. The config.yaml, I'm going to get rid of this because that's going to come later. Metadata.yaml, that we can take a look now. There's a lot of comments that I don't care about. Summary. A distributed tracing backend for Grafana Tempo. Description. Same. Then, well, we just saw that we need to wrap a container image. And as you see in the template repository created by Charmcraft Init, we already have what what Charmcraft assumes that we are most likely going to need, and which we in fact need, and that is containers. A containers directive in metadata.yaml essentially determines how many workload containers your charm is going to be deployed with. Now, that is a bit of a statement. So I think we need to take a little bit of a step back and look again at the Juju model. This is my graph. Like, everyone has their own graph of how they make sense of what Juju does. This one is mine. The way that the Juju model functions, broadly speaking, is they have a controller, the Juju controller, which talks to a unit agent, which is another component of Juju. Juju is composed of a bunch of agents. There is a unit agent, which is just a binary that gets deployed gets just copied into your charm container. It should be noted that every time that you deploy a Juju unit, there is always a container called charm. So it's not just a charm container; it's also a container called charm. In that container, there is the unit agent. The unit agent gets executed by, I think, a gRPC call from the controller. So the controller calls the unit agent. Or actually, I'm not sure if it's a polling mechanism. It doesn't matter. The unit agent then invokes the charm, calling a function, a shell script called dispatch. We're going to take a look at that in a minute. And dispatch executes charm.py. Charm.py then interacts with the workload in, typically by making calls over to Pebble. Pebble is a lightweight process manager, like in its system, specifically developed for Juju, and now we are also expanding it and using it in other contexts. But all that you need to know about Pebble right now is that is essentially like init, it's called systemd, or like a lightweight init system that runs in the container that allows you to run and configure multiple services for your container. So your container can run multiple services, not just one, as the typical Docker container would do. This workload container we call a sidecar. So that is the sidecar container. And crucially, you could have multiple ones, right? So you could have one workload container, you could have another one next to it, and they talk to, like, the charm can talk to the different containers via different Unix sockets, because that is how they talk to the different pebbles. So this is what we're defining here in containers. We're defining the topology of the charm. When a charm is deployed, it ends up in a Juju, so like it becomes a Juju unit, you could say it that way, which corresponds in Kubernetes land to a pod. A pod containing one container for the charm called charm, and the unit agent, and then one container for each workload, or at least, it doesn't need to be for a workload, but like more containers. Also, like if you omit this directive, if you omit altogether the containers directive, you're going to end up with no workload containers, which is also, it's also a pattern. It's called a workload-less charm. But right now we do need a container, so we're going to leave it there. But you could also have more than one. So if we, I don't know, we wanted to deploy Nginx next to Tempo, we would put there a second container, which then deploys another piece of software. What you need to do when you want to add a container to your Juju unit, you need to define a resource. In our case, our resource is of type, it's an OCI image. And as upstream source, which is, I would say it's not official. It's not supported by Juju. It's not a Juju directive. It's more of a useful, like I think most people use it in integration testing for determining what to deploy. But in our case, we're going to put there Grafana Tempo 150. Just any version. You could also tag latest. Now let's jump a little bit into my charm.py. As I mentioned earlier in this graph, the unit agent calls a shell script called dispatch. And let's actually take a look. So I have here a little Juju deployment with some with COSLite, I'm going to SSH to Loki 0 bash, and then I'm going to cd agents unit Loki 0 charm. So this is the charm root. You might notice that there are, actions.yaml, config.yaml, readme.md, metadata.yaml, src, and other stuff. But this is the same charm root that we have in our local repository. Right? It has the same structure. What you do when you at some point we are going to pack this charm, which means just zip it essentially, and then Juju is going to take it and unpack it in all of the units where this charm is going to end up deployed. And so the same files, we're going to see them back when Juju has deployed them. What I wanted to show you is this one. So this that is the dispatch script. It gets injected in the charm by, I think, Charmcraft. So you can also override it, by the way, if you want to. Let's look at what's in there. It's a shell script. And all that it has is a couple of environment variables and then a call to exec src charm.py. So all that dispatch does is execute the charm. So yeah, like you know Python. So you know that what happens when you execute a Python module, it executes its main function. Its main function calls ops.main. Ops is the operator framework that we developed. And main is the main entry function. We pass to the entry function this charm type, and the operator framework is going to do a bunch of stuff, like set up some wrappers that allow the charm to interact with the Juju model in, let's say, in a Pythonic way, just using a wrapper. And then it's going to emit some events on the charm, and we're going to talk about that a bit more in a bit more detail in a minute. For now, what you need to think about is the operator framework takes this charm and executes it, because the operator framework is, I would say it's a wrapper for the Juju native commands, which are called hook tools. Now it's a lot to, there's a lot of terminology, a lot of stuff in here, but I think it's useful to take a look. Tools. So in another directory in the charm, inside each charm, inside each unit, there is under tools and then the name of the unit. There is a bunch of I think they're bash scripts. I'm not sure what language they're written in. Binaries, I don't know. Anyway, these are the hook tools, and these are essentially wrappers for, I believe, HTTP or maybe gRPC. I don't know. Either way, API calls to the Juju controller. So these are the mechanism that the Juju unit agent exposes to the charm in order to allow the charm to talk back to the controller. So the flow is controller executes charm, charm uses hook tools to send data back to the controller or request more data. For example, we didn't talk about relations yet, but using relation list, the charm can get from the controller a list of the currently active relations. Or getting config get, you can request the current configuration. Using isLeader, can you ask to the controller, am I the leader? Yes or no? And vice versa, you can also push information to the controller. So you can use relation set, for example, to tell the controller, put this in my relation data. What matters for the charm right now is, and like not a lot of, I don't know, it's useful, I think, to understand what the role of the operator framework is between, Juju, charm, unit agent, and so on. The operator framework wraps these hook tools. That is 99% of what it does. So the moment that, it allows you to write charm code that does not do, popen, relation get, relation list, relation set, but talks to the Juju API using a Pythonic and just a Python interface, Python API. So especially when most of the interface goes via the model object. So for example, when you do self model config something from a charm, what you are going to, like, essentially, this is going to result into a config get hook tool call. All right, so wrapping this up a little bit, the charm runs Python code, which using the operator framework wrapper, makes hook tool calls to talk back to the Juju model, to the Juju controller. We need to understand a little bit now, well, the event model. So the operator framework works is an event-based system. The moment that ops main gets called, so when charm.py is executed by dispatch, ops main fires up the operator framework. The operator framework looks at the environment variables and decides what event to emit on the charm. Now, what is an event? For that, you better look at the Juju SDK. But what I can show you a little bit is this is a representation of the Juju event operator framework event lifecycle. I just linked in the chat. But the idea is that the charm is going to, all right, so that the operator framework inspects the environment variables that the charm is run with, and creates an event data structure. It's just simply a data structure, a Python object that wraps part of the environment, of the execution environment of the charm. And the role of an event, let's say the semantics of the event as a data structure, is to answer the question, why am I being executed right now as a charm? For example, if you, Juju deploys the charm, it deploys the workload container, and at some point that workload container is going to, come up. Docker is gonna, or not Docker, but like whatever is providing containers for Juju is going to have that container ready. Whenever that container is ready, and whenever Pebble is installed in the container, the charm is going to receive an event. That event is called Pebble ready. Whenever you configure the charm, so whenever you type Juju config some charm, some configuration option, your charm is going to receive a config change event. So to a lot of these, like you do something on the model, you reconfigure a charm, you add a relation, you remove a relation, that results into one or sometimes more multiple events on your charm, to be emitted on your charm. And the operator framework is the thing that ultimately is responsible for emitting these events. So it's not quite Juju emitting the events on the charm, it's more the operator framework. The operator framework implements the observer pattern, which you may or may not know, but the idea is that there is a self-on object that if you inherit, that your charm inherits from ops charm base. And what that on contains is a bunch of charm events. So these are all of the built-in events that you can listen to, that you can observe, that is more the terminology, that you can observe, and in response to which you can decide what to do. For example, we just mentioned the Pebble ready event. That is, the typing is not great on that one because it's dynamically, it's an event name that is dynamically generated out of metadata. So we called our container tempo. So we are going to have to listen to tempo Pebble ready. The standard practice is to call event handlers the same name of the event that they are handling plus _on prefix. So the idea is that if you are observing tempo Pebble ready event, then you're going to call your event handler on tempo Pebble ready, and config changed, on config changed, and so on. They're all private. even though charm is not really used by anything else, but that is just a convention. Now, I would say that I would split the task of developing a charm in 3 tasks, 3 sections. The first one is to decide how to install your workload, how to deploy it, how to run it, how to launch it, to set it up in a way. The second task that your charm needs to accomplish is to be able to configure that workload. So the goal of a charm is to encapsulate some high-level knobs that the user can twist and turn to make the charm do whatever it needs to do well, right? Or in the common use case, or at least covering most use cases that make sense, but reflecting the best practices. So your charm also needs to be able to configure your workload in a way that makes sense, or in the best possible way, given the parameters that the charm can be aware of. The third part is broadly operating the workload. So you have installed it, you have configured it, it's running. But a charm also manages day 2 operations on the charm. So that might include admin commands such as, I don't know, reset the root password, or burn the database, or give me a list of all of the tables that have been created. I don't know, like operations on part of the admin, or it can be operations in the sense of relations. So like when you relate one charm to one another, that's also a way of using your charm to do something together with other charms. So I would collapse that under operations. So let's go through them quickly one by one. Under installation, typically in Kubernetes, in Kubernetes charms, that means deploying your workload, and that you typically do on the pebble ready event, because that is the event that signals your container is ready. In machine world, in machine charm world, there is no pebble, there is no container. So the equivalent is, I would say, our install or start. So one of the 2 initial events. Again, if you look at this this graph, you're going to see that there is a bit of a flow. There are some events that concern a setup phase. So that is a sequence of events, or a group of events that you're going to receive in a more or less predictable order when you deploy your unit. And then there is an operation phase, which contains a bunch of events that have to do with, basically that occur contingently to whatever the operator, as in, the cloud admin is doing on the cloud. So if you add or remove a relation, you're going to receive those events, and so on. And then there is a third phase, which is the tear down phase, which are some events, not many, that occur whenever the cloud admin is destroying the charm. So pebble ready in Kubernetes, that is typically where you define and start your workload. And for that, you use the Pebble API. As I mentioned before, Pebble is this init system. It runs on the workload container, and we talk to it via a Pebble, via a Unix socket. Fortunately, we don't have to do any manual Unix socket HTTP calls. We can use the wrapper offered by the operator framework itself. The operator framework offers a container object, and that container object has all of the methods, I would say, that you need in order to deploy deploy and operate a workload. You can see more on the SDK documentation about how to interact with Pebble, but the core idea, how you might want to do this in the typical charm, is Pebble configuration consists of a number of layers. Layers can be they add up. Essentially, typically they merge. They can be merged. So whatever a layer you add later is going to be merged with the already existing ones, and so you're going to incrementally be forming a configuration for your for Pebble. That is that combine true argument you see there. A Pebble layer, so that is the basic element of configuration for Pebble. What does it look like? A Pebble layer consists of, summary description. You can guess for yourselves what those are for. Pebble layer consists of the definition of a bunch of services. Services, I would say, in the Unix sense. So it's a service is a task or a recurring process. So something that can be restarted when it errors out, or that needs to be initted by Pebble and maintained into existence. Override, replace, we don't need to look at that. Summary doesn't matter. Command. So this is essentially the entry. I would say whatever that service is, that service is running. So for example, so before we go on, let me just say that important for a configuration of a Pebble layer. So this is the startup condition. So this tells to this layer, to Pebble, should I start this service as soon as Pebble receives this new layer configuration, or should I wait on you to start it manually? But we typically want it to be started as soon as the layer is applied. The environment, that is what essentially this provides the execution environment for the command. So we specify a command and then mapping a dictionary of environment variables and values that is going to be passed to our command. A typical pattern, it's maybe not typical, I would say, but it's I would say it's a good pattern that we are increasingly using in the charming teams, is to have a separate class, a separate object that represents the workload, and then using composition, pass that object and use it from the charm, and that object should represent the workload configuration, basically. So what I'm going to do is I'm going to create a class tempo. That class tempo, what is it going to do? Its main goal is to, where's the Pebble layers? It's to contain some configuration. So I need my tempo to contain some information on on the workload container itself. So where is my tempo configuration going to be stored inside a container? Wall path, I cannot remember what this does. I'm going to move it. What are we gonna init this with? Let's suppose that all of the configuration that tempo needs is a port. Tempo ready. So we're going to initialize tempo with so like our workload. So this tempo process, this tempo service is going to be represented by this object. This object has a path to its config and a port. Then what we are going to do is we are going to define a property for the endpoint, and then a property, or yeah, just a method for the config. Now we're going to fill this in later, or actually I'm not going to fill this in at all because we just don't have time. But my idea is just I want to show you the pattern. Okay, what we're missing is tempo config path and then log path. Let's see what that's. What is going to happen as soon as we deploy this charm? This charm is going to come up. At some point, the tempo container that we requested from Juju is going to become ready. It's going to be deployed, and it's going to be running. As soon as that happens, our charm is going to receive an event. It's going to be invoked with an event, in particular pebble ready, and that is going to execute this event handler. This event handler is going to get a hold of the container provided by the operator framework, and it's going to use it to add a pebble layer to the tempo, the container. Then we're going to, replan is essentially, it's a pebble command. It means process the layers and restart yourself, or just update yourself based on the current layer configuration. The layer, in turn, we're going to generate it here. And, well, all that's missing, really, in order to get tempo up, is the tempo configuration layer. Tempo configuration, well, if we go and look at Grafana tempo, you can go and look at Grafana tempo configuration, and I don't know. For example, the Grafana tempo configuration is a big YAML file that contains, as usual, it's a big YAML. It's always a big YAML. But it contains a lot of stuff, including, I don't know, ingester configuration, configuration for all of the parts that compose tempo. You don't really need to look into it now. But suppose that we have all of that now. We have all of that here. And bar. Now we have that configuration. And well, we are executing the so our tempo layer, the pebble layer specification runs the tempo entry point, which is the same one exposed by the container. So the container contains the tempo binary, and that is its location, and it configures it. So it executes it pointing to a specific config file, which is going to be at this path. Now, if we run this charm as it is, the configuration is not going to be there because we didn't put it there. So yes. What we are missing on the tempo pebble layer, we're missing a call like this. The idea is that when pebble is ready, as soon as we have a container, the container is ready, we are going to configure tempo with the config provided by our tempo object. After that, we are adding a layer and we're replanning. So this is our, this is all you need to start tempo. We still have a couple of minutes, and I could talk a bit about configuring and relating the charm. So that's like the part 2 and 3 of creating a charm. But yeah, recapping a little bit. Creating a charm involves, you have your charmcraft in it, and that gives you the directory structure. Then the first step in writing a charm is figuring out how to deploy and get your workload to a running stage, so like how to deploy it. Essentially automating what you would do if you were locally to do Docker run whatever Docker image you're talking about. Then you need to figure out how to configure this thing, and finally how to operate it.
Thank you very much, Pietro, for hosting this beginner workshop. And I think this is the first time we're actually having a beginner workshop on focusing on Kubernetes kind of charms, right?
Could be, because usually you're giving them, and then it's all machine.
Exactly. So this was great. I learned a lot from this.